solve the differential equation d cube minus 3d minus 2 into y equal to x square. Again the q of x is nothing but in the form of x power k. This is also called, it is a polynomial in terms of x. It is a higher order differential equation. Every higher order differential equation in the form of f of d into y equal to q of x, where f of d equal to d cube minus 3d minus 2, q of x equal to x square. To solve this differential equation, the general solution of this differential equation is y equal to yc plus yp, means complementary function plus particular integral. To calculate the complementary function, you have to choose auxiliary equation f of m equal to 0, that implies m cube minus 3m minus 2 equal to 0, means replace d by m. When you are replacing d by m, then automatically we are getting auxiliary equation, that m cube minus 3m minus 2 equal to 0. If you are calculating these roots by using scientific calculator or by general method, m equal to 2 comma 1 comma 1. Therefore, the complementary function according to our complementary function formula, yc equal to repeated roots, for the we are writing repeated roots, c1 plus c2x into e power x plus c3 into e power 2x. Now, calculate the particular integral. Yp equal to the general formula of the particular integral, yp equal to 1 by f of d into q of x, that equal to 1 by d cube minus 3d minus 2 into x square. Then you convert the what is the denominator part, d cube minus 3d minus 2. Then this 1 by f of d you have to convert in the above 6 formulas. Just now I told you, means 1 plus x whole inverse or 1 minus x whole inverse or 1 plus x whole to the power of minus 2, like that you convert into that quantity. Then what I will do, the first of all you have to observe this one, the coefficient, you take the coefficient common from the denominator, then minus 2 is there, then I am taking minus 2 is common from the denominator, then it becomes outside minus 1 by 2. If the constant is not available, then you have to consider d is the common. Then this can be written as 1 minus d cube minus 3d by 2. 1 minus d cube minus 3d by 2 whole to the power of minus 1 into x square. Then we are writing like this, it is in the form of 1 minus x whole to the power of minus 1. Then we have the formula 1 minus x whole to the power of minus 1 means 1 plus x square. Then here the power of x is 2, then you have to expand up to square term only. Then minus 1 by 2 is outside, 1 plus x, x means this total term is x, d cube minus 3d plus 2 minus x square means d cube minus 3d by 2 whole square into x square. Then outside is minus 1 by 2, x square into 1, x square, again d cube of x square, d cube minus 3d by 2 into x square, then d cube minus 3d by 2 whole square into x square. Now what I will do, I am doing directly x square, d cube of x square is 0, minus 3 by 2 into 2x, minus 3 by 2 into d of x square, d means capital D is nothing but differentiation of x square with respect to x. Then d of x square means 2x differentiation of x square. Then d cube minus 3d by 2 whole square. Whole square means a minus b whole square. A square means d cube whole square means d power 6, it becomes d power 6. B square means 3 minus 3 by 2, 3 plus 3 by 2 d whole square means 9 by 4 d square of x square is 2. The next 2ab means it becomes d power 4. I have not written here, d power 4 of x square is nothing but 0. Then minus half into x square, minus 2 cancel, minus 3x, then this is nothing but minus 9 by 2. Therefore y equal to yc plus yp. Then yc equal to c1 plus c2x into e power x plus c3 e power 2x. This is our complementary function, and particular integral is minus 1 by 2 x square minus 3x minus 9 by 2 is the complementary function. We are adding all these things. This is our general solution of the given differential equation.